Today, let us do the problems on Poisson distribution. The first question is, a random variable x follows Poisson distribution with mean 1. Calculate the probability that x equal to 0, x equal to 1, x greater than or equal to 2. So that we are given for Poisson distribution mean equal to 1. That is, we have mean equal to lambda for Poisson distribution. It is given, okay? So that we may assume, therefore, x follows Poisson with the lambda equal to 1. That is, f of x equal to e raised to minus lambda, lambda raised to x by x factorial, which is e raised to minus 1 into 1 raised to x by x factorial equal to e raised to minus 1 by x factorial, x equal to 0, 1, 2, etc. Okay. Now, it is required to find the first part is probability x equal to 0. That is simply e raised to minus 1 by 0 factorial. E raised to minus 1 is 0.3678. 0 factorial is 1. So that this is the answer. For part 2, it is required probability x equal to 1. It is from this function e raised to minus 1 by 1 factorial. We know 1 factorial is equal to 1. So that the same answer 0.3678. Okay. Now it is required to find the probability x greater than or equal to 2. X greater than or equal to 2 is the event x equal to 2, 3, etc. up to infinity. So we may consider the complementary part. That is, it is equal to 1 minus probability x less than 2. Greater than or equal to, as it is a discrete random variable, for the event x greater than or equal to 2, its complementary event is x less than 2. That is, x takes value 0 and 1. So, equal to 1 minus bracket probability x equal to 0 plus probability x equal to 1. Okay, we already have these probabilities. That is 1 minus 0.3678 plus 0.3678. That is the answer is 0.264. You can check the calculation part, okay? Now question number 2 is, between the hours 2 p.m. and 4 p.m. the average number of phone calls per minute coming into the switchboard of a company is 2.35. Find the probability that during one particular minute there will be at most 2 phone calls. Okay, you are given the average number of phone calls per minute coming into the switchboard. That is, we may take x as the number of phone calls per minute, so that average is lambda, okay, for Poisson distribution. So, we may take question number 2, let x be the number of phone calls per minute. Be the number of phone calls per minute. So that we are given lambda equal to 1, lambda equal to mean equal to 2.35. That is lambda equal to 2.35. Therefore, we may assume x as Poisson. Lambda equal to 2.35 implies f of x equal to e raised to minus lambda, lambda raised to x by x factorial. So, equal to e raised to minus 2.35 into 2.35 raised to x by x factorial, x equal to 0, 1, 2, etc. Now the question is find the probability that there will be at most 2 phone calls per minute. Okay, at most 2 in the sense, what is meant by at most 2? It is maximum 2. Therefore, required probability equal to probability of at most 2 phone calls. At most 2 phone calls, which is probability x less than or equal to 2, maximum 2. That is x takes value 0, 1 and 2. So that probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. Okay. Probability x equal to 0 is, what is it? It is obtained as e raised to minus 2.35. Okay, into 2.35. We know f of 0 as e raised to minus lambda. So the next is e raised to minus 2.35 into 2.35 raised to 1 by 1 factorial plus e raised to minus 2.35 into 2.35 raised to 2 by 2 factorial. This is the required probability and you can do the calculation part. Okay. We come to question number 3. Given that in a book of 520 pages, 390 typographical errors occur. Assuming Poisson law for the number of errors per page, find the probability that in a random sample of 5 pages, a random sample of 5 pages will contain no error. Okay, we are given 520 pages. Out of 520 pages, there are 390 typographical errors. So that we may take x as a number of typographical errors per page. Number of errors per page. Number of errors per page. Okay, therefore x follows Poisson lambda, we may assume, and lambda equal to the mean equal to 390 by 520. Okay. Total 520 pages and 390 errors occur. So that 390 by 520, it gives the value 390 by 520 equal to, it is 0.75. Okay. Therefore, we may assume x follows Poisson lambda equal to 0.75. And hence f of x equal to e raised to minus lambda raised to x by x factorial equal to e raised to minus 0.75 into 0.75 raised to x by x factorial. X taking value 0, 1, 2, etc. Okay, now we are considering x as a number of errors per page. So we need to find a probability no error in 5 pages. So that it is required to find a probability x equal to 0 in 5 pages. That is probability x equal to 0 in 5 pages. That is probability x equal to 0 whole raised to 5. It is required one. Okay. Required probability is probability x equal to probability 5 pages will contain no error. Will contain no error. That is probability. We may consider, I may write here. That is required probability equal to probability x equal to 0 whole raised to 5. Okay, I will once again explain. It is the required one is probability 5 pages will contain no error. That is, per page is taken as x, error per page is taken as x. So that probability x equal to 0 whole raised to 5 is the required one. So what about, we know f of 0 as e raised to minus 0.75. It is whole raised to 5. Okay. So that e raised to, we may obtain e raised to minus 0.75. It is equal to 0.4724, 0.4724 whole raised to 5. It is equal to raised to 5. It is enough. Raised to 5. That is, it is 0.024. 0.024. I may explain once again. We are considering x as the number of errors per page and given that lambda equal to out of 520 pages 390 errors occur. So that mean lambda equal to 390 by 520. Now it is therefore we can obtain f of x. Now it is required to find the probability that 5 pages will contain no error. So we can obtain probability x equal to 0. It gives the probability of no error in a per page. So that whole raised to 5 gives the required probability, and this is the answer. You may check for calculation. Okay. Now we consider the next question. A manufacturer of pins knows that on an average 5% of his products is defective. He sells pins in boxes of 100 and guarantee that no more than 4 pins will be defective. Find the probability that a box will meet the guaranteed quality. Okay, so this question is the application of binomial distribution. That is, we know as binomial distribution tends to Poisson distribution, as n tends to infinity, p tends to 0, such that np equal to lambda is finite. Okay, we consider question number 4. So this is the solution for question number 4. So this is an application of binomial distribution to Poisson distribution. That is we made here we are given p as the probability of a defective equal to 5% is 5 by 100. It is 0.05. Okay, and we are given he sells in boxes of 100, that is n equal to 100. So application of binomial to Poisson distribution. Application of Poisson distribution as a limiting case of binomial distribution. Okay, that is since n equal to 100 and p equal to 0.05, that is n large p small, n large p small. We may take Poisson. We use Poisson distribution. That is lambda equal to np equal to 100 into 0.05 equal to, what is it, 100 into 0.05, it is equal to 5. Therefore, x follows Poisson lambda equal to 5. which gives what about f of x equal to e raised to minus lambda raised to x by x factorial equal to e raised to minus 5 raised to x by x factorial, x taking values 0, 1, 2, etc. Okay. Now, what is the required one? We move on to this side. So that, what is the required one? What is the probability that the box will meet the guaranteed quality? And what is his guarantee? He guaranteed that no more than 4 pins will be defective. No more than 4 pins will be defective. Therefore, required probability becomes probability x less than or equal to 4. Okay, maximum up to 4 pins. He guarantees up to 4 pins that it will be defective. That is probability x less than or equal to 4. So what is it? It is equal to probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2 plus probability x equal to 3 plus probability x equal to 4. Isn't it? Probability x equal to 0 plus etc. up to probability x equal to 4. So that we may simply calculate using this f of x. That is, it gives, firstly we know probability x equal to 0 is e raised to minus lambda. So e raised to minus 5 plus e raised to minus 5 into 5 by 1 factorial plus e raised to minus 5 into 5 square by 2 factorial plus e raised to minus 5 into 5 cube by 3 factorial plus e raised to minus 5 into 5 raised to 4 by 4 factorial. It is the required one and you can do the calculations. Okay, this is the required answer. Okay, thank you.